This video will help you fill out your lab sheet for Investigation 1 in kaleidoscopes, hubcaps, and mirrors. And this lab sheet basically covers the lessons in Investigation 1, problems 1.1 through 1.4. This lab sheet condenses the information in Investigation 1 in your book, problems 1.1 through 1.4, and it allows you to take some notes on your page that you can refer back to later, and then also complete the exercises that you're assigned. Like with any paper, the first thing you're going to want to do is put your information on your paper, your name and date and period and all that kind of stuff. You'll notice that this has a table where we can take some notes and talk about the 3 types of symmetry that are listed in your book. The butterfly and the heart pictures are examples of what we call reflection symmetry. So you're going to want to write that right here on your lab sheet. Now as you watch this video, you're welcome to put any notes or ideas right over here on this side of the lab sheet. And that's what we did in class. And you'll also notice that there are a couple places here, here, and here where you can write more definitions that are specific to that type of symmetry. And that first type of symmetry, called reflection symmetry, it's called that because the image has a reflection. If you were to draw a line through the middle of this butterfly vertically, you could fold that butterfly over on itself, and each half of the butterfly would be a mirror image of the other half. So we call that reflection symmetry. The heart also has reflection symmetry here at that line, also with a vertical line. The line of symmetry is not always vertical. It can go in any direction as long as you could fold the object on itself on that line. Now you notice this green line is not a line of symmetry because you cannot fold the heart on that line and have each half of it overlay on the other half exactly. The same with a horizontal line on this butterfly. Reflection symmetry can also be seen by a mirror, thus the name reflection symmetry. If you placed a mirror along the halfway point of the heart, you would see the other half of the heart reflected in the mirror to make a full picture. Sometimes an object or a figure has more than one line of symmetry. And so over here on your lab sheet, you might want to write something about lines of symmetry, and those are the point on a figure where you could fold an object over on itself to make 2 equal halves. And you might notice that the fan in the next picture does not have any lines of symmetry. If we draw a vertical line, the fan does not fold over on itself to make 2 equal halves. If we draw a horizontal line, it's not symmetrical there by reflection. If we draw a diagonal line, it doesn't work, and so on. What the fan picture does have is called rotation symmetry. So under the type of symmetry on your lab sheet right here, you want to write rotation symmetry. If the figure has rotation symmetry, you can rotate the figure counterclockwise and it will make an exact copy of itself after a certain degree of rotation. So if you look at this fan, we can rotate this upper blade around until it turns into that side blade, essentially. The center of rotation is where you rotate the figure around the point that's fixed. It's kind of like taking a nail and nailing through the center of the picture so that your object will spin around that nail. And the angle of rotation is how many degrees it has to turn counterclockwise to make a copy of itself. To find out the angle of rotation, we need to remember that a circle has 360 degrees in total. So in our fan picture, for example, we can think of this as dividing it into sections that are equal in size. So I could rotate this fan 1/3 of the way around a circle and have it make a copy of itself. So that I take 360 degrees and I divide it by the sections. It means that I'm going to have an exact copy every time I rotate the fan counterclockwise 120 degrees. This would be called the angle of rotation. Now, it would also make a copy for every multiple of 120 degrees. So in this case, it would make a copy at 240 degrees and then again at 360 degrees. So let's look at the third type of symmetry. The strip of paper with the fish on it is an example of what we call translation symmetry. So you're going to want to write translation symmetry right there on your lab sheet. Notice this fish pattern that keeps repeating itself. Now that fish pattern is not rotated, and there are no lines of symmetry where you can reflect the fish over itself. What happens with translation symmetry is that the object is moved or slid from one place to another. In fact, we call translation slides. Translation symmetry is often used to make these wallpaper patterns or neat art designs, which we may be doing later on in our class. One of the things that's important about translation symmetry is when you describe it, you need to specify the distance and direction the object is moving. Sometimes we draw an arrow from one of the figures to a copy of the figure to show the direction and describe the translation. Now, I've described the basics of the three types of symmetry, and hopefully you've got some notes down. The next part of your lab sheet requires that you read through problems 1.1 through 1.4. As you read through those problems, you'll notice that I've covered part of the material, but you'll also find some more little nuggets of information in the text, and then you'll use that to answer these questions for yourself on the lab sheet. When you have that done, you're ready to begin the problems. They start with problem 1.1, reflection symmetry. In problem 1.1, the first thing you're asked to do is to find all the lines of symmetry in each figure below. Sometimes a figure has one, or sometimes it has many lines of symmetry, and sometimes it has none at all. Remember that when you find a line of symmetry, that the entire figure needs to be able to be folded over that line and make an exact copy of itself. In other words, each half is exactly the same as the other half, folded across that line of symmetry. Problem 1.2 deals with rotation symmetry. And we start with this pinwheel figure. If we turn it counterclockwise a certain number of degrees, it will make an exact copy of itself. So not surprisingly, we know the center of rotation is at the center of the figure, right there in the middle. And the next thing we need to find is the angle of rotation of this figure. So to do that, I remember that in a complete revolution, we have 360 degrees. And if I look at the figure here, it's divided into little wedges, like so. And I can count the number of segments on my circle. Looks like I've got 1, 2, 3, 4, 5, 6, 7, 8. If I take the total number of degrees in a revolution, 360, and I divide it by the number of segments I have in my figure, which is 8, I get 45 degrees. So the angle of rotation of this pinwheel figure is 45 degrees. That's what it took us to rotate it from where it was to where it is right now. That also means that we'll make an exact copy of this figure by rotating it in multiples of 45 degrees. So if I rotate it 45 degrees, I get a copy, and another 45, or a total of 90 degrees, I get another copy, and so on. So now back to the lab sheet. On problem 1.2, on part A, we already talked about that. You just need to answer the questions involved with that. Now in the following questions, you need to apply what we just talked about to these other figures, the windmill, the snowflake, and the wagon wheel. And then finally, you ask some kind of questions about these two hubcaps with some interesting designs. After you finish that part, we're on to problem 1.4, which is translation symmetry. So if you look at the tiled pattern here, problem 1.4 is going to ask you to describe the shape that's being repeated or tiled, and secondly, explain how it's being translated or slid to make this picture. So far we have combined lessons 1.1 through 1.4. You may have noticed we didn't do any questions from 1.3. They were all integrated into the other questions. So now that you have some experience with that, it's time for our ACE questions. We put together this page of ACE questions from all 3 lessons to help you practice these skills that you've learned. Make note as you're doing these questions that you are answering the questions correctly, paying attention to what kind of symmetry it's asking you to discuss or display your knowledge of, and make sure you're following all the directions. For example, sometimes it'll say to tell about something, and other times it might say to draw something. And feel free to draw and write and answer your questions right on this page and use additional pages if necessary. If you have any other questions about this video or about this topic in math, feel free to email me at this email address or check out my website listed below.